All right, so get this. We're going deep on software design patterns this time.
Oh, yeah.
Yeah, specifically something called Singleton. I know. Might sound a little dry at first.
All right.
But think of it this way. Like, we're learning the secret handshake.
Mm-hmm.
The secret handshake of, like, expert programmers. You know what I mean?
Yeah, that's a good way to put it. Design patterns, they're all about finding these elegant solutions.
Right.
To common problems you run into when you're designing software. And Singleton, that's a fascinating one.
Yeah.
It's all about control, making sure you only have one instance of something in your entire program.
Okay, so like only one president at a time.
Exactly.
Or like a master key.
Yeah, like a master key that unlocks every door. Perfect analogy. And you know what's cool?
What?
Our source material, it actually uses this example to illustrate the point. It's a travel agency called Acest.
Acest, okay.
But it's in another language, which just goes to show you that these concepts, they're truly universal.
That's really interesting, actually. Yeah, that makes a lot of sense.
Absolutely. And this is where things get really interesting. This source material dives into how.
Okay.
Without a Singleton, this Acest agency, they could actually end up selling the same travel package.
Oh, no.
Twice.
Yeah.
Imagine the chaos. You got double bookings.
Yeah, that's a disaster.
Angry customers.
Acest. Even with the Singleton, that name, like, it's just asking for trouble.
Yeah, maybe. But anyway, back to the point. A Singleton, it would prevent this by essentially acting as a gatekeeper.
Okay.
Only letting one person in at a time. Think of it like, you know those VIP clubs?
Yeah.
Where they've got that one strict bouncer?
Right.
Only lets one person in at a time.
So it's like, even if some like rogue code or something tries to create a second Acest, the Singleton is there to say, nope, we've already got one. That's all we need.
Exactly. You got it.
Yeah.
Now, to get a little bit more technical.
Okay, yeah.
The way this is achieved is through something called a private constructor. It's like locking the door to creating new instances directly. So the only way in is through a special method.
Okay.
And that method checks, hey, does an instance already exist? And if it doesn't, then it creates one.
So that special method, that's like our super selective bouncer then.
Exactly. Now, the source material, it also goes into different types of singletons.
Oh, interesting. So I guess not all bouncers are created equal.
Exactly. You got it. It talks about eager versus lazy initialization.
Eager versus lazy. Okay.
Eager means the single instance, it's created right away, as soon as your program starts.
So that's like preheating the oven.
Exactly. So it's ready to go.
Makes sense. So then lazy would be like, you only turn the oven on when you need it.
Exactly.
More efficient, but maybe you have to wait a bit.
You got it. A slight delay the first time, but it also goes even deeper. Mentions thread-safe singletons.
Thread-safe, okay.
This gets into like a whole other level of complexity.
Oh, boy.
This is when multiple parts of your program, right, they might be trying to access the singleton at the same time, which could cause some problems, some conflicts.
So it's like things are getting really busy at our club now.
Exactly.
We need a really good bouncer.
You need a really, really good bouncer to keep things running smoothly.
Yeah. So the source material, what does it say about how to do this thread-safe stuff?
It explains how these thread-safe implementations, they use all these clever techniques to make sure that even with all this simultaneous activity going on, only one instance is ever created or accessed.
Okay, so now we've got the basics, right?
Yeah.
We know what a singleton is.
Yeah.
We know the different ways it can be implemented. But there's something I'm curious about.
Yeah.
What about a static class?
Ah, good question.
Because on the surface, they sound kind of similar, right?
Yeah, and the source material, it makes a really key distinction here.
Okay.
Think of a static class like a toolbox, full of utility functions. It's always there. Anyone can use it. A singleton, on the other hand, it's like a single specialized tool that you can pass around and share. But it's still unique. There's only one of them.
So it's not just about being single.
Right.
It's about how that single instance can actually be used and interacted with.
You got it. A static class is more like a fixed utility in a workshop.
Right.
Whereas a singleton is a tool that you can actively use and manipulate in different parts of your code.
Okay, that actually makes a lot of sense. So what about this singleton collection thing?
Oh yeah, the singleton collection.
What is that all about?
The source refers to it as a registry for managing multiple but unique items.
So is it like a group of unique items, but they're all managed under one roof?
That's a great way to think about it, yeah.
Okay.
It's like having a collection of like one-of-a-kind artifacts.
Yeah.
Each carefully controlled access through a central system.
Wow, so we've gone from like a single bouncer at a club to like a whole museum of unique artifacts.
Exactly.
All thanks to this Singleton idea.
All variations on this Singleton idea.
Yeah, that's pretty wild.
And what's fascinating is that this concept can be applied to real-world scenarios.
Okay.
Far beyond our little travel agency example.
Oh, really? Like what?
Well, for example, the source material talks about managing database connections.
Database connections, okay.
Yeah, so imagine you have this web application.
Okay.
And you've got tons of users, right?
Uh-huh.
All trying to access data at the same time.
Yeah.
A Singleton can make sure there's only one connection open.
Right.
At any given time.
Okay.
Which prevents conflicts.
Makes sense.
And potential data corruption.
Ah, so it's like instead of 100 people all trying to squeeze through the same door at once,
right.
The Singleton is there to be like, all right, everyone line up one at a time.
Exactly. It's about managing those resources.
Yeah.
And making things efficient.
Right, right.
And depending on what you're into, you might already be interacting with Singletons.
Yeah.
Without even knowing it. For example, the source talks about shared preferences.
Shared preference?
Yeah, and Android development.
Okay.
Basically, it uses a Singleton to store user preferences for an app.
So even if I'm not a coder, like there's a chance a Singleton is working behind the scenes.
Absolutely.
Making sure my app remembers like my language settings or something.
Exactly. Things like that, yeah.
Huh, that's pretty cool.
Yeah, and it even gets into a more complex example.
Okay.
Document Builder Factory in Android.
Builder Factory.
Yeah, uses a Singleton to make sure that XML documents are created in a very specific, very controlled way.
So we've gone from managing database connections to like fine-tuning how documents are built.
You got it.
Singletons really are starting to feel like the Swiss Army knife of design patterns.
Yeah, you're catching on. But here's what's really interesting.
Okay.
Singletons can be combined with other design patterns.
Oh, really?
Like the factory or builder pattern.
Factory and builder?
Yeah, and together they can create even more powerful systems.
Now, hold on. Are we talking about a factory that only produces one thing at a time?
Well, that's where the nuance comes in.
Okay.
Think of a factory that can build custom cars.
Right.
That's your builder pattern.
Okay.
But there's only one assembly line.
Right.
That's your Singleton.
So you can make lots of different kinds of cars.
Exact.
But only one car is being built at any given time.
You got it. So we're adding this level of control over the creation process itself.
Yeah. We're not just managing a single instance.
Right.
But making sure we're only creating unique things within that framework.
Precisely.
That's really clever.
And that's just scratching the surface.
Okay.
Now, the source material focuses mainly on the benefits of Singletons.
Yeah.
But it's important to acknowledge that this pattern, it's not without its critics.
Wait, really? I thought we were all aboard the Singleton hype train here.
Right.
What could possibly be wrong with the pattern that brings so much order and control?
Well, one argument against Singletons is that they can lead to something we call tight coupling in code.
Tight coupling.
Yeah, because the Singleton instance is globally accessible.
Right.
Other parts of your program can become heavily reliant on it.
So it's like having a single point of failure.
Yeah, that's one way to think about it.
If something goes wrong with the Singleton, a lot of other things break as well.
That's the potential risk.
Right.
And this tight coupling, it can also make testing your code more difficult.
Oh, how so?
Because isolating the Singleton to see how it behaves in different situations, that gets tricky.
So it's not just about whether a Singleton works,
right,
but also how easily you can make changes or fix problems down the road.
Exactly. Maintainability becomes an issue.
Gotcha.
And some critics even argue that Singletons go against the principles of object-oriented programming.
Interesting.
Because they introduce global state and potentially hide dependencies.
So it's like we've stumbled upon the dark side of the Singleton.
Yeah, maybe a little dramatic.
It's powerful, but maybe a bit too power hungry.
Well, the point is valid.
Okay.
It's important to understand the trade-offs before using Singletons in your code.
Right.
They're not a magic bullet.
No silver bullet.
But a tool to be used strategically.
Right. So there's a lot more to consider than just one instance good, many instances bad.
Exactly.
But even with these potential downsides, I'm still struck by how this seemingly simple concept has such huge implications for software design.
What fascinates me is how this idea of ensuring uniqueness, it ties into this broader theme in software development, our desire for order and control.
Right.
over these complex systems.
It's like we're trying to tame the Wild West of code by imposing these rules and constraints that make it easier to manage and predict.
You got it.
And singletons are one of our tools for achieving that order.
Precisely. And the fact that this pattern appears in so many different programming languages.
Right.
And contexts speaks to its fundamental value.
So it's not just a quirk of one language or framework. Right. It's a deeper reflection of how we think about structuring software and solving problems.
And that makes it even more valuable to understand, even if you're not a programmer, recognizing these underlying patterns can give you a deeper appreciation for how the software you use every day is built.
It's like being able to read the language of the digital world.
Yeah.
Even if you can't write it yourself.
Exactly.
But speaking of writing, I'm curious about actually implementing a singleton in code.
Oh, yeah.
I know it's going to be different depending on the language.
Right.
But are there any common elements?
Definitely. The source provides a good overview.
Okay.
First, you need that private constructor we talked about.
Got it. Exclusivity is key.
Exactly. It's like putting a lock on the door.
Right.
To creating new instances directly.
What else?
Then you need a static method. That acts as our gatekeeper.
Gatekeeper, right.
This method is responsible for either creating the single instance or fetching it if it already exists.
So it's like our meticulous bouncer, checking ID, making sure only one person gets in.
Exactly.
Even if there's a huge line forming outside.
And to store this precious instance, you need a static variable.
Okay.
Think of it as a secure vault.
All right.
Where the singleton resides, safe from unauthorized access.
So we've got the lock, the bouncer, and the vault.
Exactly.
So what's the final piece of the puzzle?
The logic within the gatekeeper method itself.
Okay.
This is where you'll check if an instance already exists.
Right.
Create one if needed.
Okay.
And then return the instance to whoever requested it.
So it's like a create if needed, otherwise retrieve kind of situation.
Precisely.
Makes sense.
The gatekeeper ensures that no matter how many times it's called, only one instance ever exists.
Got it.
It's elegant in its simplicity.
Okay, so we've covered a lot of ground here.
We have.
We explored the singleton pattern from its problem-solving origins to its different types, real-world applications.
Absolutely.
And even its potential downsides.
We did.
And we even touched on how it interacts with other design patterns to create even more sophisticated systems.
Yeah, sure.
But I think what has really stuck with me is this idea that the singleton isn't just about code.
Right.
It's a reflection of how we think about problem solving.
Absolutely.
About imposing order on complexity.
That's a great takeaway.
Yeah, it is.
And I think that's a perfect place to transition to our final thoughts on the singleton and what it all means.
So we've explored the singleton's technical nuts and bolts.
Well, you have.
And even, delved into some philosophical territory there.
Right.
But before we go, I'm really curious. Yeah. What's your big takeaway from all of this? What's the most significant insight about the singleton pattern?
What really stands out to me is how this seemingly simple idea, this idea of just making sure there's only one of something, it has such a huge impact on software design.
Yeah.
It's a testament to the power of constraints.
Constraints, okay.
By limiting variability, right? We gain control and predictability. And that's so crucial in these complex systems.
It's like setting boundaries, but those boundaries actually enable creativity.
Exactly.
We saw how singletons can be combined with other patterns.
Yeah.
Adding this level of finesse to how we create and manage these unique objects.
Right.
But it all starts with that one simple rule. Only one.
Exactly. And it makes me think about how this concept might apply outside of programming.
Oh, interesting.
Are there systems in our everyday lives that rely on this same principle?
Okay.
This principle of singularity for stability or control.
Ooh, I like where you're going with this. What comes to mind?
Well, think about something like air traffic control.
Okay. Air traffic control.
You can't have multiple planes.
Right.
Trying to occupy the same airspace at the same time.
Yeah, that would be bad.
There needs to be that central authority, a single source of truth.
Right.
That coordinates everything to ensure safety.
It's like our singleton bouncer, but with way higher stakes.
Exactly.
Or what about a national currency?
Oh, yeah.
There's only one official currency issued by a government, right? Which helps stabilize the economy and prevent chaos.
Precisely. And even in nature, we see examples of this.
Oh, really?
Think of a beehive.
Okay, a beehive.
There's only one queen bee.
Right.
A single point of control for the whole colony.
I'm starting to see singletons everywhere now.
It's everywhere.
It's kind of amazing how this pattern, which we first started exploring in the context of just a travel agency, can actually be applied to so many different domains.
It really highlights the importance of looking for those underlying patterns, those principles, whether you're designing software or analyzing systems in the real world.
Yeah, that's a great point.
The singleton is a reminder that sometimes less is truly more.
It's about achieving elegance through constraint.
Exactly.
Finding power in simplicity.
Absolutely.
And on that note, I think it's time to wrap up this deep dive.
I think so too.
But before we go, I want to leave our listeners with one final thought.
Okay.
As you go about your day today, try to notice systems that rely on this concept of singularity. Where do you see the singleton pattern at work?
Right.
Either explicitly or implicitly.
Good question.
It's like a little game of spot the singleton in everyday life.
I like it.
And if you discover any particularly interesting examples, let us know.
Yeah, share them with us. We'd love to hear your insights.
Absolutely.
And until next time, keep exploring this fascinating world.
Yeah.
This fascinating world of design patterns.
It's really quite something.
Who knows what other elegant solutions are out there waiting to be discovered.
Happy pattern hunting, everyone.